For the problem 1, the first question says P represents a probability mass function, so it has the probability that the integral of this probability mass function from k equals to 0 to infinity should equal to 1. So we have this summation and from k equal to 0 to infinity equal to 1. And since we know that p is 0 to 1, and we have 1 plus p to the power of 2, this equal to 1 minus p of 1. And this can be equal, also write as the summation of k equal to 0 to infinity of p the power of k. And if we take derivative of this equation, we have equals to 1 divide 1 minus p to the power of 2. And this is equation 1, this is equation 2. So to calculate the value of b, we just take 1 divide 2, and we directly got b equals to 1 minus p to the power of 2. And this is for the problem A. And for the problem B, we need to calculate the expected value of E. So we have the formula of expected value equals to the summation of px equal to k times k, where k is from 0 to infinity. And plug in the formula we'll get from part A. We have k power of 2 times 1 minus p power of 2. This is the value of b as we calculate, times p the power of k minus 1. And because as we can see from this formula that if we take the derivative of equation 2 as stated in the left side, we have got that if we times the equation 2 by q, equation 2 times p, we got k times p to the power of k, and it is equals to p divide 1 minus q to the power of 2. And if we take derivative of this function, we can get that the summation of k the power of 2 times p the power of k minus 1 equals to the derivative of this. And compare to this formula and this formula, we just know that the expected value of E should equals to the derivative of p divided by 1 minus p to the power of 2 times times 1 minus p the power of 2, and after calculation we have got the expected value of e equals to 1 minus p 1 plus p, and this is the expected value of e. And the reason that we would like to use the equation 2 times p and take derivative is that we observe that there is the power of k the power of 2 in my expected result. So I try to get the k's power of 2. So I think that I can use the equation 2 times p and then take the derivative. And this is for the problem B. And for the problem C, we would like to calculate the expected value of the x the power of 2. And by plugging the formula, we got that this equals to the summation of from k equals to 0 to infinity the k power of 3 times 1 minus p the power of 2 times p the power of k minus 1. And since in B we have got that the summation of k equals to 0 to infinity k the power of 2 times p the power of k minus 1 equals to 1 plus p divided 1 minus p the power of 3. And applying the same procedure we have done in part B, we just denote this formula as 3 after we times p of equation 3, and we have got that the summation of k equals to 0 to infinity k the power of 2 times p the power of k equals to this equation, and then we take derivative with respect to p of this equation. We got that and this is exactly the formula of e the power the expected value of e divided by 1 minus p of 2. So after we calculate this equation, so by calculation and plug in the formula, we have got that the expected value of x the power of 2 equals to 1 minus p power of 2 equals to this value, which is p the power of 2 plus 4p plus 1 divide 1 minus p the power of 2. And this is for the problem C. I just need to make this part smaller. Sorry. And for the problem D, we need to calculate this part, and we just need to plug in the result we have got in problem C and problem B, and we get that it is equals to this value. This is the result we got from problem C. This is the result we got from problem B, and it is equals to 2p divided 1 minus p to the power of 2. And this is for part D. And the last part E, we need to find the conditional probability mass function given that p is equals to 1 divided by 3. And with p equals to 1 divided by 3, we can write the probability mass function as we need to plug in the value of p, and we get this value. It is 4 divided by 3 times k times 1 divided by 3 the power of k, and this is for the probability mass function. And for the thing that we need to calculate, we expand it. It is equals to the probability of x equals to k. At the same time, x is from 2 to 5. Divide the summation of probability from k from 2 to 5. And we just plug in the formula. We have got the value equals to 2.4796 k times 1 divided by 3 the power of k, and this is for the k is from 2, 3, 4, 5, and the probability equals to 0 when k equals to other value. And this is for the problem 1 of homework 3. And I think in this problem it is kind of practice. We should have the intuitive to know that, for example, we need to take derivative of this side of this function, and we need to times this function to get what we have to calculate for the expected value.